Morning, boss.
How are you today?
Fine, thanks. So where are we going today?
Well, today we've got to go and fix...
And more from today's news. A local plumber died when he was electrocuted whilst carrying out work in his home yesterday. The health and safety executive are assisting the police and local authority with their investigation into the incident.
Wow, that's terrible. How could a plumber get an electric shock working at a house?
Sometimes it's part of the job to work with or near to electrical equipment. That's why you need to know the basics of electrical safety. And you need to know your limits. You know, it only takes a small amount of current to kill you. 40 milliamps is enough, and that's a fraction of what's needed to run a 40-watt light bulb. We've got a few jobs on today that could involve electrics, so I'll show you how we can get the job done safely. See, there are electrical controls on that boiler and the water heater, and in the bathroom there could be an electric shower, a heated towel rail, or shower pump, and you can even get electrics on the kitchen sink. You see, you might not actually be working on the electrical components, but you still need to be safe when you're working on the equipment, and you need to know your limits. Don't try and do what you haven't been trained for.
I see. What voltages are actually dangerous?
All voltages can be dangerous. It depends on the circumstances. Even a very low voltage, such as from a battery, can produce a spark and ignite an explosive atmosphere, such as near a gas leak. But it's when you get over 50 volts that most people are at risk. Contact can cause a range of injuries from shock, including breathing and heart problems. And not only that, don't forget that you could lose control if you're working at heights or near moving machinery. You could even fall off a ladder, and that can be fatal. For example, let's take a look at the current needed to light a 60-watt lamp. At half a milliamp, most people will feel a tingling sensation. At 3 milliamps, the tingling sensation begins to hurt. At 10 milliamps, the muscles convulse. That's why you may have heard people say they couldn't let go when they had a shock. At 30 milliamps, RCD protection is set to trip fast. Anything above this level is dangerous. At 40 milliamps, the respiration is affected, and the victim can die from suffocation. At 100 milliamps, we see ventricular fibrillation and interference with your heartbeat. It's usually fatal. At 250 milliamps, the current needed to light a 60-watt lamp is sufficient to electrocute 5 people simultaneously. Today, we're going to be changing this heating pump.
Okay.
So first, we need to identify potential hazards by checking for damage to equipment and recognizing where there are live circuits. Select the right tools and equipment and make sure they are in good condition. Make sure that we can isolate securely. That means making sure the power is off and that it stays off. Follow safe working procedures.